Alright, for this question, I've tried to have a dual page view because it's a large question and we do need to see what's going on. So read the facts given, and our first part is find the size of the angle OAB. Alright, just by looking at this, it is a triangle, this shape, and we can see that we've been given the opposite length and we've been given a pair already. So we can use the sine rule. So sine A and its corresponding length is 3.4 is equal to, and then we write down one pair. So sine pi by 6 over 1.9. We just cross multiply, so 3.4 times sine pi by 6 over 1.9. Alright, so solving that, we get sine A, which is 17 over 19. Let's inverse sine that. So first of all, if we were to inverse sine this, we get A to be like 1.1078 and so on. However, this is not what we want because first of all, it's an obtuse angle. We can see over here that angle OAB is greater than pi over 2. So what we have to do is we have to remember the rule that sine theta is equal to sine 180, or pi in this case, minus theta. This is usually in the case when they give you that the angle is obtuse and we have to use this method. So we just do pi minus our answer, which is the 1.1, and we get our actual angle OAB, which is 2.034. It does say to 4 significant figures. That's our first part solved. Made some space for us, and the second part is finding the area of the triangle OAB. So we're just going to look at this triangle. It's not right angled and we are working with angles, so I'm going to assume we have to use the rule half AB sine C, and they have like confirmed 2 lengths already, so finding lengths can be quite lengthy. So we're going to use the lengths that we already know. So we're going to do half multiplied by 3.4 multiplied by 1.9, and then we want this angle. This is our angle C. To find that, it would be, we know that all angles in a triangle add up to 180, or pi in this sense. So pi minus pi by 6 minus our 2.034, and we just plug that in our calculator to get our answer to be 1.78. Given that the ratio of the area of the sector OBC to the area of the triangle OAB is 3 to 2, show that the angle BOC is 0.462 radians to 3 significant figures. All right, wonderful. So our first hint is that we're given the ratio, and we've already found the area of the triangle OAB. So let's work with that. So this is the area of the sector, and this is the area of the triangle. The ratio is 3 to 2. We have found the area of the triangle to be 1.78, and we want to first find the area of the sector. So let's cross multiply and do 1.78 multiplied by 3 over 2. It's also really just multiplied by 3 over 2, and we get the area of the sector to be 2.67. All right, so that's the area of the sector. And then we know that the area of the sector, the formula is half theta r squared. And we're trying to find this angle, aren't we, BOC. So that's our theta. So we know that our r is 3.4 because the length has already been given. So a half multiplied by theta multiplied by 3.4 squared is equal to 2.67. So really, if we were to just multiply everything, we know that our theta we bring to the other side, 2.67 over a half times 3.4 squared. We get our answer to be 0.462. Hence, find the perimeter of the badge in centimeters to the nearest integer. Right, wonderful. Now, my little tip with these types of questions, because it is lengthy and we usually make the silliest mistakes, write down what we need to find the perimeter. We know we need OA plus AB plus BC plus CO. So what do we know? We know that BA is 1.9. We know that CO is 3.4 because it is a sector, so it is a radius. And we're trying to find OA and we're trying to find BC. Let's do the easiest ones first. BC, which is a arc length, we know that the formula is just going to be S is equal to r theta. So our r, which is 3.4, multiplied the angle, which we just found, multiplied by 0.462, we get our arc length to be, let's just write it as 1.57. So here we go, 1.57, fill in the blanks. And now we're trying to find OA. So it is a triangle, and what we can do is use the cosine rule. Right, so let's remember the cosine rule. A squared is equal to B squared plus C squared minus 2BC cos A. Right, so we're trying to find this length, and the corresponding angle would be this one. This is the corresponding angle. Perfect. So let's take B as 3.4 squared plus C. Our C is 1.9. Now let's work with the lengths we do know. Minus same lengths, 3.4 and 1.9, 2. Multiplied by cos A. Our A is the corresponding angle, which we know is going to be pi minus pi by 6 minus 2.034. Yes. Right, so we just solved that, put that in our calculator. Should be getting something around 4.41, but then we do have to square root this because this is a squared. So our A is going to be equal to 2.1. Go. And then we just add all these up, find the sum. 2.1 plus 1.9 plus 1.57 plus 3.4. And I am personally getting the answer to be 8.97. However, they are asking for the nearest integer, so we just round that to 9 centimeters. And perfect, that is the 8th question done.